Hello, I welcome you all to this another interesting screencast. The problem reads the boats A and B travel with constant speeds of VA equal to 15 meters per second and VB equal to 10 meters per second when they leave the pier at O at the same time. Determine the distance between them when T is equal to 4 seconds. This problem is coming from the Engineering Mechanics Dynamics 14th edition by R.C. Benam. So we are dealing with relative motion. And we are being asked to determine the distance between the two boats that leave the pier at the same time. So we want to determine the distance between them when t is equal to 4 seconds, but they leave the pier at the same time. Okay, right. So let's assume that both boats are translating, okay, and no change in direction. Therefore, we can either use RBA, RAB, that's the position of A with relative to B, or RBA. We can use any of this. Okay, we can use this. Therefore, we can either use VA stroke B, okay, velocity of A relative to B, or VB stroke A. Okay, so let's use VB stroke. We use VB stroke A. Okay, we can use either. We have just chosen this one. Let's use this. Right. So we know that the relative velocity of B with relative to A is equal to VB minus VA. Okay. So VA and VB are absolute velocities, and by this we mean they are observed from a fixed reference frame. In our case, is point O. Okay, this is where we are observing them from point O. And VBA is a relative velocity that we are going to observe, like in our case, from the translating reference frame, which will be A. So A will be our translating reference frame. Okay. All right. So A will be our translating reference frame. Let's call this one as X prime and a Y prime. While the fixed reference frame is this one. Okay. This is the fixed reference frame. Okay. Right. So having said that, so let's find out the components of these. So we'll have components for A and B so that we sum up these particular vectors. So we'll have components like so. We'll have another component like so. Okay. And we'll also have a component like so. And another component like so. So let's work out this. So this one, I do the angle here. The angle, this angle here is 60, and then this angle here is 30 degrees. Therefore, this is going to be equal to VB sine 60, and this one will be VB cos 60. And this one here, this one is going to be equal to VA sine 30, and this one here is VA cos 30. Alright, so let's find out what these are. We can now simply say this therefore is going to be equal to VB. We know what it is, so let's plug in VB here. So it is 10. We have 10 in the x-axis, 10 cos 60 I plus 10 sine 60 j minus this is 15 cos 30 I plus 15 sine 30 j. Alright, therefore our VBA is going to be equal to, let's sum up this. So we have 10 cos 60 plus, or minus rather, minus 15 cos 30. What do we get? So we get a minus 7.99 I. So let's sum up the other one. 10 sine 60 minus 15 sine 30. So this one we have a 1.16 J. Okay, where VBX is equal to a minus 7.99. Okay, let me just try to go through this again. So 10 sine 60, 10 sine 60 minus 15 sine 30. Okay, it's fine. So let me close it like so, and then say meters per second, and then I'll say our VB AX is equal to a minus 7.99 meters per second, and our VB stroke AY is equal to 1.16 meters per second. So let's find the magnitude of this. So we know that magnitude of this is equal to just the square root of VB AX squared plus VB AY squared. This therefore gives us our VB magnitude is equal to, grab your calculator, we have 7.99 squared plus 1.16 squared. Square root of that, we have 8.0, since I'm still working, 0.7377. I've lengthened it like this. I think I can just say 8.07 meters per second. Alright, since we know that VBA is equal to dr BA with respect to time. Therefore, we can say our DRBA is equal to VBA dt. And if we integrate both sides, 0 to S distance and 0 to T like so, then we are going to have RBA is equal to integral from 0 to T of 8.07 dt. Okay, then RBA is just going to be equal to 8.07 T. Okay, then RBA at time equal to 4 seconds is just going to be equal to multiply that's 8.07 by 4. This gives us a 32.28 meters. Okay, so this is our distance. This is our distance between the two boats at time equal to 4 seconds. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.